Hello, my name's Matthew. I work on the slicing software here at BigRep. Our slicing software is called BLADE, and it is used on all our printers to take your 3D computer designs and turn them into instructions that create in real parts. BigRep BLADE is our preferred slicing software because it contains all of our material profiles, all of our machines, and all of our specific setups that make it easier to use. So once you have downloaded and installed the BLADE software, you can open it up and get started. The first thing you'll want to do is have a 3D print file and open it within BLADE. The easiest way to do this is to simply take your STL or 3MF file and drag and drop it into the software. Alternatively, you can of course use Ctrl-O or File Open or any other method you prefer. Once this is done, we have a single piece, and this can be moved around, scaled, translated, rotated, or have numerous other features done. But this is a topic for another time. The primary feature that you'll need to change is your material and your nozzle. So to choose different material options, there is a wide array provided by BigRep. And additionally, we have a list of generic materials. So if you're working with your own materials, you can select these and then tune your profiles as required. For this example, we'll stick with the default material of black PLX. If, however, you want to look and find out some more information about what's available, we have the material profile table. And this will provide an overview for your specific printer of which materials have which layer thicknesses and associated nozzles. If, however, for one material, you need some additional information, you can either click on the link in the materials table or within BLADE, and this will take you to the store page, which provides additional material information such as the MSDS, data sheet, and default temperatures, etc. Once you've chosen a correct material, you need to pick your particular print settings. Because BigRep develops multiple profiles, they are already tuned to the particular machine and use case. However, sometimes you may need to change some of these settings depending on your exact application. So there is a general overview of settings here, and if you need access to all the settings, you can click on Show Custom, and then you have availability of every single setting in a completely open source manner. There is nothing hidden. You are able to change anything at all to your heart's desire. However, it's recommended that you use the default profiles because these have been tested by the company and will work as well as possible. Once you've got your initial setup, you can click Slice, and this takes your 3D shape, breaks it into a series of layers, and creates the specific instructions that the machine will use. If you want to view these instructions, you can click Preview, and you are actually able to see the options layer by layer and detect, inspect, or certify that things are going to happen as you like before you actually begin a print. Once you're happy with all your settings and options, you can save this file, and using Connect or placing it directly on your printer, if networking is not available, you can then start a print. Additionally, if you have a complicated setup that you may need access to in the future, you're actually able to save a project file. This can be accessed by pressing Ctrl-S or by going File, Save Project, and this will save a 3MF file. A 3MF file is a combination of your geometry, of your settings, of your material, of your machine setup, and other features, so that when you come back to BLADE later, all of these will be loaded automatically. So if we are to start again from a fresh setup, we can reload a 3MF file that we have here, and you'll see that all the settings will be restored exactly as they were when you saved a project. The final thing that I would like to show you today is dual extrusion printing. So it's very common that when you have multiple parts, you may need to print with multiple materials. So for this example, I would copy and paste the original part and we'll print one with one material and one with another material. So once you have more than one part available, you need to decide which part is printed with which nozzle. So to do this, you simply select the part that you're interested in, and in the bottom left corner, you will choose either extruder 0 or extruder 1. So in this example, you can see that extruder 0 is used on the left part, and extruder 1 is used on the right part. Then you slice exactly the same as before, and you save the G-code. You should take care though that any G-code that you put on a printer should match up with the materials and settings on said printer. If you use the Connect software, this will be checked for you, and it will warn you if your G-code does not match the current style of the printer. Okay, so one of the features within Blade that is very useful, especially on large-scale printers, is bring customization, and is available here at the very bottom of the toolbar. For this example, we'll use automatic, and you can see that small additional adhesion points are added to the corner of the part. So providing this little extra bit of adhesion can just help make your part stick to the bed a little bit better, and this will improve the reliability and quality of the outcome. So there is a large number of potential orientations for any given part in 3D space, and not all of them are created equal, depending on the shape that you're using. So it is important that we pick a really good orientation to minimize the amount of support. Support is not desirable because it's just wasted material. At the end of the print, you have to throw it away. So to try and minimize this, we have the auto orientation tool. This tool will take a part and go through a large number of potential orientations, calculate the amount of support required, and choose an option that minimizes the support. So if we take our example here, we can rotate it to a random configuration that is not very optimal. And then we can use the auto orientation tool, and we will see that it will take the part and reorient it in a way where there is the minimal amount of support of a given design. Gradual infill is an important feature in 3D printing when speed is really important. So what is infill? It is the extra material that is added inside the walls of your 3D object. So we can see it here in the preview that our infill is a crosshatch shake. However, the majority of the inside of this part doesn't actually need material there. If we have less material, the part would be lighter, it would print quicker, and a lot of the strength of a part actually comes from the walls. So if high density infill is not required, it's very convenient and very useful to use what's known as gradual infill. To access gradual infill, we'll go to our custom settings. Once you check this, there are additional features that you can add. However, just turning it on already provides the best default settings as per our material profile. So you will have to reslice the part because we've changed the settings, and we can do that now. And you'll see that the new infill pattern actually changes depending on how close to a wall or a roof you are. So when we're at the top of the part, we start moving down and the infill is very dense because we're near a wall. But as we get further into the middle of the part, the infill density drops. So in situations where gradual infill is possible and an option, it's recommended that you use it. Please be aware though, gradual infill will increase the slicing time a little bit. Okay, so additional to gradual infill, there is also one more option that provides a similar capability. This is lightning infill. This is quicker to print and uses less material, but if it is not possible for you to use this kind of pattern because you need repeatable properties, then use just gradual infill or regular infill. Similar to infill, but for support structures, we can choose to change from regular support to a tree support. This has the advantage of using less support material while still maintaining contact with the entire surface area. To do this, we open the support section and we scroll down to support structure type and we choose tree support. But As you can see, we now have tree support, which has far less material usage, and the bottom of our support only contacts the build platform. This will happen whenever possible, and it means that when you remove support, you only remove the support from the overhanging features. You don't have to remove them from the entire part. So that was a quick overview of the BigRep BLADE software. Hopefully it's enough to get you started on your printing journey. However, if you want extra information or extra insights, feel free to contact us. We have an academy and other features that hopefully can help you, and we'd love to get in touch.